What's going on? What's wrong? Oh shit, you're right here. Huh. Yo, chill. Did you log out and log back in?
And that picture you said is something about approved next to CCNA.
No, that's just. Come up here real quick. Let me see you real quick. Your phone? Yeah.
You need me to log into it on my phone?
Yeah.
Okay.
Are you up on your computer over
Yeah,
there?
I am.
Okay, I'll walk over there.
It was like that all last week.
You sign in with Google?
No.
Okay,
I
sign
can
in
log
again.
in with my.
Yeah, log in again real quick. Okay. Let me just wait till lunch. I'll have it fixed. It's probably a bug. All right, y'all ready to get started today? We're probably gonna end early because, no, we are gonna end early because my voice. So what we're gonna go over right now is NAT. So we're gonna go over network address translation. We're gonna go over DNS, probably SNMP, syslog, and then we're gonna be done for the day. All right, and then I'm gonna give you guys like homework to go watch videos after class. Okay, so NAT, network address translation. This is how we convert RFC 1918 addresses, which are private IPs, to public IPs. So RFC 1918 addresses, that is this range of IPs. Okay, so you'll have to know these ranges. You have to know that these are private IPs and that they're not routable on the internet. So those IPs cannot go to an ISP. We came up with these IPs to conserve public IPv4 addresses. And then NAT, network address translation, is going to translate those private IPs into a public IP. So here's how it'll look. We have our router here, and then we'll have our inside network or our local area network. So this will be 10.0.0.0/24. And then we'll have our outside network. And this will be whatever is facing our ISP. Okay. So this will be our public IP address that we get assigned from our ISP. Let's say we're R1 here. And we have 3 types of NAT that you're going to have to know. So we have static NAT, which is a 1-to-1 mapping. And what we mean by that is essentially if you have one public IP, only one private IP address can get translated into that public IP. And then we have dynamic NAT. And that's a many-to-many mapping. So this is kind of, I don't know what like a good use case for it, but essentially this says, hey, if I have a pool of public IPs here, like .1 to .3, so that's 4 IP addresses, I can translate 4 private IPs. So it's kind of almost like still a one-to-one mapping, but now we have a pool of public IPs, okay? Now what we're going to configure and what you need to know about, and that it's happening right now, like the network we're on to reach the internet is PAT, port address translation, which is a 1-to-many mapping. So that is taking one public IP and allowing hundreds of private IP addresses to get translated by it, which is what we're doing right now. All your computers are on like a 10.0.0.0 network, and one public IP is being used. So let me bring up Chrome here. I think I showed you guys this the other day, but if we type in what is my public IP, you can see that that comes up. But if you did IP config, it would be like 10.0.0.0 something. So you need to understand these 3 different types. But for configuration, I'm going to show you how to configure PAT. So here's how PAT looks. Let me draw this out. PAT, port address translation. So we have our user connected to a switch, connected to our router, ISP, and we got to talk to a web server. So this will be a web server. So this will be 17.1.1.1.1. Right here we'll have 209. Actually, we'll make this short. 2.3.1. Okay? Oh, let me do it this way. So this will be dot 0. This will be dot 1 over here. And then we have our inside network. So that vernacular I'm using is very important. The inside network is going to be your private IPs, okay? Inside network. The interface facing the internet, facing your ISP, is always going to be the outside network. So let's just say this is gig 0/1, and this is gig 0/0. So gig 01 is our outside interface. Gig 00 is our inside interface. You're going to have to understand that for the exam. So this user here will be 10.0.0.5. So let's say that this PC1 here wants to talk to this web server. And we have a PAT-enabled router here. This is our PAT-enabled router. So what's going to happen when PC1 builds that layer 3 header? And we're going to put a socket in there as well. So we're going to put the ports as well, okay? So this will be our layer 3 header. And now this is going to be our layer 4 header. What the hell? So our layer 4 header is going to have a source port and a destination port. So this is going to be a source port. This is going to be a destination port. So if we're talking to a web server, what port number are we going to use? Anybody know? 443 or 80? I'm just going to do 80 here because it's a smaller number. Hold on. What the fuck is called? Okay, I don't know what that is. And then this source port is going to be something ephemeral, okay? So there's an ephemeral port range that is just random. So we have like well-known ports and we have registered ports that are going to be controlled by an organization called IANA, like IANA, and we can't use them. So like port 80 is always going to be used for HTTP. But we also have ephemeral ports that can be randomly used. So that's what's going to be our source port. It'll be like 6.1.1.1.4. And then our source IP and destination IP. So our source is going to be 10.0.0.5. Our destination is going to be 17.1.1.1. So when this entire socket, this entire packet hits this PAT-enabled router, what's going to happen is it's going to translate that source IP into this public IP, and then it's going to maintain a table that says, hey, this private IP is linked to this source port. So now our socket's going to look like this. It's going to leave our ISP with our new source IP, which will be 2220. The same destination. It's going to have the same port numbers. So 6.1.1.1.4, and then 80. But we're going to maintain a table. In that table, it's going to say, hey, this private IP, 10.0.0.5, is always linked to that port, 6.1.1.4, okay? So this matters, because once we send that off to the web server now, and the web server responds, here's what its packet's going to look like. So this web server's source IP is going to be itself. The destination IP will be 2220. The source port will be port 80, but then the destination port will be 61114. And when that reaches the router's going to see that, oh, this is trying to talk to 6114. That's mapped to this private IP. So since it's mapped to that private IP, I know to send this packet from the web server to my private PC right here. And that's the entire flow of PAT. It just maintains this state table here that says, okay, when all my private IP users talk, I'm going to track their source port, put it in a table, and then when the receiver, which is the web server in this case, sends traffic back, I'm going to take note and be like, okay, it's destined for this port. That's mapped to this private IP address. Okay, go ahead. Okay. All right. Is there any questions here about how PAT works? It's just that table that really matters, that PAT table. We call it a NAT table in Cisco. All right, now here's how we configure it. And you're going to have to know this, so take notes. So we take a look at this. All right, so R1. So the first step is going to be we're going to define what IP addresses need to be translated. So we're going to do that with something called an access list. So we'll say access list 10. And then we're going to put the network that needs to be translated. So it'll actually be access list 10, permit 10.0.0, and then a wildcard mask. So that's step one, is define the private IP addresses that need to be translated. Hold on real quick. Okay, so this number right here, guys, that's the access list number. Like I had like numbers for OSPF, HSRP, same thing, access list 10. And then we're going to do our NAT statement. So this is the important part. So we're going to say IP NAT inside source list, then the ACL number, and then we got to choose the interface that's going to be doing the translation. So in our case, that's gig 01. That's the outside interface that's actually translating a private IP to a public IP. So it'll be interface, gig 01. Then here's the most important part of this, the overload command. This overload command is what makes it PAT. If I miss this, this is just going to be like static NAT, okay? I need that overload command. All right, so step one, define the private IPs. Step two, do your NAT statement. The important thing you have to remember here is obviously the ACL number, the actual interface, and then this key command here, overload, is what makes it PAT. You may get a question like that, like, oh, how do we configure PAT? What's the command that makes it PAT? And then next, we have to define our inside and outside interfaces. So let's do that. Change this back to black. So our inside interface is going to be what's facing our private IPs. So that's a gig 00. And we're going to do IP NAT inside. So we're really going in now and saying, hey, you're the inside or you're the outside interface. And then we're going to go into interface gig 01. And this is going to be our outside. And that's it. That's entire PAT configuration. Pretty simple. What you might see on the exam is something like a show command. It'll be like, why is NAT not working? And what's missing is these commands here. You forgot to define the inside and outside interfaces. Okay, let me check some real quick, guys. All right. This is pretty much all you need to know for NAT. I'm going to bring up on the PowerPoints some show commands so you can like see what you have to look for. Let me present this.
John,
Yeah.
good question.
Yeah.
Is that 10 always, is that a constant number for the access list, or is that designated by the?
No. It's just it's a random number you pick.
Okay.
Yeah. You're gonna configure access lists probably like tomorrow, and you'll see. It's just like random. Okay, so check out this command here. Show IPNAT translations. So you can see this table that's being maintained. So you see this inside local. That gets translated to our inside global, which is just the outside IP, but it's maintaining this table. You see how the ports are the exact same? And then the outside local and the outside global are always the same. Because essentially what that's saying is, hey, when our PC made the destination IP in that packet, here's what it was. And then the moment it leaves our router, it stays the same. Because remember, destination IP address never changes, ever. Source IP address, go ahead.
I have a quick question. I don't know if this is jumping ahead, but for something like port forwarding, would you port your, like the inside local port to 51839 to be able to access, like go outside of the network?
Port forwarding.
Port forwarding. Or am I confusing?
I think you're talking about when you're at your house and you have to enable port forwarding.
Yeah, that's fine.
And that's so the ISP allows certain ports in through like their ISP network. Yeah, it's okay. PAT is already done on your home router, but then like when people from the outside want to talk in because you're gaming and technically you're like game there needs to access something local, that's from the outside letting in. This is just inside to outside connectivity. Yeah. Okay. But yeah, there's a table that's important. Inside local gets translated to the inside global, and that port is maintained. Okay, look at this command. All right. Y'all see this? Outside interface, inside interface. This needs to be populated with something. On the exam, this is the question I was talking about, where they'll show you this, and they'll be like, why is NAT not working? It's because, I can't remember which one, but it's like one of these is missing, okay? So you need to be able to look at this show command, like what is it telling me? It's telling me what the inside interface is defined as. It also tells me my pool, which this is dynamic NAT, but if we're doing PAT, it'll just show you the ACL as well.
What told you it was dynamic on that, looking at that?
This pool, dynamic has a pool, start to end. PAT doesn't have a pool, it's just an outside interface because it's a one-to-many mapping. You won't need to know that, but in clear, we don't need to know these show commands. Okay. Any questions on that? All right. So what key command makes it PAT? Overload. Okay. That's another important one you need to know. All right, let's go ahead and take 10, come back at 10:05, and then we'll get started on DNS. Mhm.
So could you like mess up the configuration for the inside and outside?
Yeah, you can fuck it up.
So what would happen? Like you just
Just wouldn't work. You wouldn't reach the internet. Yeah. Like every single ISP has like a deny at ACL for this range of IPs. Like every single ISP. Every time you get on a network, you're always going to get an IP address in this range. You'll never get assigned a public IP directly. Now, what's the only caveat to that is SIPR. SIPR will have like random IPs that are in this range, but those aren't public IPs, right? Because it's a closed off network. But
Zipper, you build a subnet yourself.
it's just random, yeah. SIPR's not. It's
So like when we give you your subnet for your node, that's something that's designated like before the node even gets to you. So since you think of them as private IPs, but it's something that's given to you.
okay. Let's see here. Let's start your guys' labs. All right, guys. Let's go over DNS. So this is the domain name system. So to get started, everybody go on your laptops, open up a command prompt for me. This is going to be the same on MacBook too. So if you have to open up terminal, everyone type in this command, nslookup. We'll do trepatech.com. Just like on the just like on the screen here. Okay. So we can see with this command, we can actually see the name resolution, our domain name to our IP address mapping. So trepatech.com belongs to this public IP. So what is this system? So when me and you browse the internet, we go based off the URL, the domain name. So google.com, facebook.com. But computers, they talk in IP addressing, which we talked about. They talk in binary really, but right, that's IP addressing. So DNS is the way that we can resolve host names, domain names, to IP addressing. So to go over a domain name, kind of break it down. So trepatech.com. This .com here is the actual top level domain, okay? So TLD. Y'all mind putting that on mute?
I'm trying to.
All right.
I'm trying to put it down.
Okay.
It's not.
It's all good. Okay, so this .com is top level. What we mean by that is there's going to be hundreds or thousands of other domain names a part of that top level domain. This could be a .net. This could be .org. What is your guys' top level domain name in the Army? .mil. And then other domains are a part of that, okay? Now when we add something like www, which stands for like World Wide Web, that is called a CNAME, a canonical name. I'm just gonna put CN. Just an additional identifier to that. Now when you guys add computers to Active Directory, so you add them to, well, in my job it was SOCOM.mil. I don't know what you guys added to. But if you want to look up the fully qualified domain name, it would be that computer name .army.mil, whatever your guys' domain is. So an FQDN would be like computer name dot your domain name dot your top level domain. So for when I was in soft, that'd be computer name dot socom dot mil. Okay? So if you ever see FQDN, fully qualified domain name is what that means. So like troubleshooting a user's PC, what I would always do is I would ask them for the computer name and I would ping that, right? They'd be like, I have no connectivity. That lets you check a couple things. Is that computer on the domain? And is DNS resolving, okay? Because you can do a ping test. Let me bring up my terminal again. Like this. You can ping just a domain name. And that lets me know, okay, DNS is working, and I have IP reachability. Now let's go over how the flow of DNS. So we have PC1 here. You go into the web browser, you type in trepatech.com, and you need to get to that web server. So before all that, we need to do a DNS request. So this PC is going to do a DNS request, and it's going to hit its DNS resolver first. This is also called the recursive DNS server. You may hear it two different ways. So I'll put a little pipe here. Recursive DNS. So this is something that technically sits local. So when you go home, your ISP is your first DNS hop. That's your DNS resolver. That's your recursive DNS. So your default gateway, if it's like 192.168.0.1, that's also going to be your DNS server. And that's just the ISP doing it for you. So let's say this is the very first request, and our DNS resolver doesn't have that in its list. It doesn't have trepatech.com. What it's going to do is it's going to forward that request to a root server. There's only physically 13 DNS root servers in the entire world, okay? Physically. Oh, excuse me. Not physically, opposite. There's only 13 organizations in the world that have a DNS root server. So we're going to send that request. We're going to say, hey, who is trepatech.com? We're looking for the IP. And the root server is going to say, hey, I don't have that exact record. I don't have the exact record that says trepatech.com is this IP address. What I do know is that the .com top-level domain belongs here. So we're going to get that request back. The resolver is going to say, okay, now I need to go ask this TLD server. So hey, TLD server, who is trepatech.com? The top-level domain server is going to say, hey, I don't know, but what I do have is a list of name servers. And I know exactly which name server trepatech.com belongs to. So it's going to respond back saying, hey, I don't know, but I know that this name server will have that domain. And then finally, our DNS resolver is going to send that request to the name server. This is where we actually live. This is where trepatech.com actually has all of its records, okay? So we're going to say, hey, name server, who is trepatech.com? And they're finally going to respond with the IP address. And that's the entire flow. And then the resolver now has that, so it's going to put it in its list. So the next time another user asks for it, the DNS resolver knows right away. Hey, yeah, trepatech.com is equal to 104.1.1.1. That's the full DNS flow. Now let me show you guys what a real DNS server looks like. Let me bring up. Actually, I won't show you guys this because I'm streaming live. So never mind. Oh, yeah, I don't need to show you that. That's okay. I'll show you a fake one. So we know that that's the flow for everything. But what are these records? So every single DNS server is going to have different records. Really, a DNS server is just like a long, to me, like a long spreadsheet of A records, quad A records, CNAME records, and a bunch of different records that we're going to go over. Okay, so check it out. You guys know what the cloud is? Oh, well, I guess I'm teaching you Wednesday. But this is Azure, Microsoft Azure. I have this domain name attached to it, trepatechnology.com. And if these are the records I have for it. So we're about to go over the different record types there are. We see this type right here. So this is saying who my name servers are. So trepatechnology.com belongs to these name servers. If I want to add like an A record, so let's say I want to add another record here. I can just put, let's do ftp.trepatechnology.com, and I'll set the IP address. And we can add it here. Now this is in Azure, so this is Azure managing DNS, but this is very similar to Google, like GoDaddy has its own DNS. All these different hosting services will manage DNS for your domain name. Has anyone here ever bought a domain name before? Start a website? It's pretty fucking easy, right? So you just go here, buy a domain name. Hold on, let's see. So we'll go to Squarespace. So let's say we want 82nd Airborne. Let's see. Let's see if we can buy this. Oh, look. That one's actually pretty, someone could mistake that. 82ndairborne.com. 82nd Airborne, what the fuck? Let's see. Yeah, they don't have the actual one. Let's see if that's an actual. Nice. What is this? Someone owns this shit. It's on Wix. They're hosting it on Wix. All right, whatever. But it's really that easy. So, like even us, Trepa Tech, I don't know any other company named Trepa Tech, so that one was easy to buy. But yeah, you can look up, you can buy this, and then you'll manage your domain name here. So if you need to go add all these different DNS record types, you'll do it from Squarespace. If you're ever a cloud engineer and Azure is your cloud, this is how you might manage it as well. All right, let's go over these records here, and I'm going to bring up the slides for this. All right, yeah. So DNS servers will have DNS records, which are text instructions stored on a DNS server. So an A record, that's the most common one. This is the DNS record that you need. So this is your host name to your IP address. You need to know this, okay? There may be a drag and drop on the exam that's like describing a record, and you have to say, oh, that's an A record, okay? Quad A record is the exact same thing, just for IPv6. So when I buy a new domain name, like the 82nd-airborne.com, and I host it on a website, I need that A record for the whole internet to be able to access it. All right, CNAME record. This is going to map an alias. So yeah, www dot something is a CNAME record. I don't know why. I think when the internet came out, that was like, I don't know why we started doing www, but like, when I built Trepa Tech, I didn't make that CNAME record because I just put trepatech.com now. I think because back in the day, like FTP dot something was like available. People could FTP to your server. But anyways. Okay, you don't even know that one. A pointer record. So this is like the reverse, okay? This is like pointing an IP to a host name, okay? And this is for verification. Then we have our NS record. So this is what's telling our domain name, hey, this is your name server. Did I miss anything? Okay. There's one record in here that's not on my CCNA slides that I want you guys to know. That's an MX record. Mail exchange. What the fuck? So if you have an MX record, in your DNS server, that's pointing to an email server, okay? It's for email, MX. There's other ones too called SPF records and DMARC records. I'll keep it simple with you guys. This is just for security and verification. Verification. Damn, why is my pen acting crazy today? All right. There's also something called a text record. Actually, it doesn't matter. You don't even know that. I'm not going to get too deep. Okay, so now on Cisco iOS, we can actually tell our router to resolve to a DNS server as well. So let me get into a router here and show you guys. So remember, have you ever put in at privilege mode the wrong command, then it says translating, and you're stuck there with all 255s? That's DNS. So by default, your Cisco router is trying to resolve that. It's like, this isn't a command, so maybe you're trying to access a website or something, so we're going to send a broadcast to a DNS server, okay? So I'm going to show you a couple different things here. One, how to set this router to point to a DNS resolver. So that's like 8.8.8, 1.1.1.1. I'm also going to show you how to turn off DNS. So how to tell that router, hey, we don't need to like search for anything via DNS. I'll let this boot up. Do you guys remember when I showed you how to SSH to a device in Cisco and I put an IP address? And some organizations, they'll SSH using hostname as well. So they'll put in a router like a bunch of A records that host all your switches and everything, their actual host names. So instead of memorizing IP addresses, you'll just be like, oh, switch 1, floor 1. But in some environments, they'll do that. Let this boot up real quick. Hold on. Okay. Come on. Okay. Do you guys see that? I just put in some random characters. It's like translating, domain name server or domain server. So we don't have a DNS resolver set on this router. We're not telling this router to point to any DNS. So it's just going to do that broadcast IP, okay? But if we want to set one, memorize this command. Do IP name server. Then we can do like 8.8.8. And that's from global configuration mode. Okay, so now I got cut off by the screen here, but I just typed in random characters again. You see, now it's trying to resolve to 8.8.8, and we're going to be stuck here for a little bit. In a real router, if you hit Control-C or Control-Shift-6X, that'll stop this. But okay. Now if we don't, let me do something real quick. If we don't want any domain name lookups, any DNS resolution at all, we can type in no IP domain lookup. And then that turns it off on the entire router. All right, if we want to put an A record on here, so we can actually put A records on the router itself, and that'll let us resolve to like our switch's host names. We can do like switch 1, floor 1.trepatech.com. Oops. And then the IP address, so whatever that is, 192.168.1.15. And that is us creating an A record on our router. We type in do show host. Oh, wait. There we go. You can see we have it right there. So if I were to go here and like hit SSH, hold on, let me put a user. TAC L, Cisco. It would try to point me here, okay? So we didn't get an error there, because now it recognized that host name. Obviously we got like, hey, it's not reachable, but because I don't have it configured or set up. But. Okay, any questions, guys, on DNS? So what you need to know for the exam, if I ask you what an A record is, you should know that maps a host name to an IP address. If I ask you what a quad A record is, that's the same thing, just IPv6. And then an MX record is for mail, email, okay? Mail exchange. There used to be, well, it's a big test dome, so it probably still is, but there's a couple drag and drops like that. It wants you to like, hey, drag this A record to the right definition, you know? So, all right, what we got? 10:30? All right, come back at 10:40. I'm going to go over 2 more things, and we're going to be done for the day. Because I don't know if y'all can tell, my voice is fucking hurts right now. But I'm going to give you guys homework, okay? I'm going to have you watch videos at home and shit. So, all right, come back at 10:40.
Where'd you get that router from?
Our labs. Yeah, that's our labs. You watched us do the labs last week?
I caught a couple.
Okay, I got you. Yeah. Tomorrow I'm going to have you guys do a couple labs, so you'll see. Yeah.
You know if there's anywhere you could just like buy a router kit and then download it YouTube?
Well, the software I use, yeah, you could use. It's all free. You can buy. I bought physical routers when I first started out on like eBay and shit, like for $400. Yeah. Like Wednesday, I'm gonna come here with like a router, switch, and a wireless controller, and like I bought all that for pretty cheap. Yeah.
Nah, I stayed up though. I had to nap earlier. Yeah, I'm about to borrow you because I told Mark the best to the movies, get his ass the tour.
It was crazy. Every time they just did something random that I
They didn't know what he's doing.
like before it was just
He actually didn't know what he was
It
doing.
was like it's like a remix, speed up.
but this is weird. Like over
I'm like, he ain't got no arm, he ain't got no leg. He ain't even 5 minutes in.
They should be the days built for
How you got to that point? Yeah, I met them in the movie. Two of them ended up getting murdered. Oh no, I gotta watch some season 2 now. I can't go back. EOP now. I don't care. I had been telling myself I'm gonna get into it, but then I never do. But now it's like I done got caught up on everything else. So I'm just like, man, I gotta start somewhere. So I tried to watch Black Clover like a year ago. It was just slow.
Did you get one of these? There you go. What's up? Let me get one of your Red Bulls, dog. No, I'm just kidding. What you want, dog? We're not doing labs today, so you're good. Yeah.
You gotta think about it.
That's your VM. Just go on the web and put that IP address in, and it'll bring it up.
I'm at the end where like he done fought Moira
Can I see this real quick?
and he done said his dad and all the people that died came back.
Do I have that shit in there?
And then now Taylor like these things. But the last thing I watched.
Okay, I do have that shit in there. The DNS stuff. I didn't know if I put it in there or not.
I was, you know, when you was talking about the net and the pet, I started going, well, I'm like, it's not baked in there. I went for it. I said, oh, this
Yeah. I teach how to order sometimes.
is fine. That's so much. Because this right table
Yeah, that book has like everything pretty much to pass the exam on it. Pretty much.
I was been studying this for about 6 months. I was 3 months. I would have been.
Y'all don't learn this shit in AIT? Or you do?
Nah, the only thing I learned in AIT is the OIS model, and then we really stopped once we got the switches and routers.
Just the hotels do or something? Yeah.
Probably the Bravo.
Uniforms after the subnet.
Yeah.
We started learning some of the configs and stuff like that, and then some of the commands, but we stopped. We never used CP run. We never used that, but we heard of it.
Yeah, like CDP. Is anybody at 25 Hotel here? Y'all learn this shit in AIT?
No.
No?
Some of it, not to the
No.
extent, it doesn't go deep dive like this.
What about the Bravos? Any Bravos in here? Do y'all learn this in AIT?
All of the 25 series, they do a basic networking like class in AIT during like the first 2 weeks, and then after that, it's
Yeah. You know, for Bravos, I'm surprised they would dive deep into this shit if they do.
We actually did learn most of this. ACL, OSPF.
That's funny though, because you guys are help desk though, not networks. You figured they'd focus on Windows and Microsoft more.
That's what we learned when I first part of class.
Yeah. With what?
The second half of our training was like networking. We did like all this stuff.
For Sierras?
Not all.
Oh, you're a Bravo? Yeah. Do y'all learn CCNA then essentially?
No, we learned. He said the same thing. Cause we did learn the commands whenever we stopped and learn how to clean it. We learned stuff like that. But that's all in the second half.
I remember you saying what it is. I gotta remember you know garlic.
But I'm just saying it's simple. I'm putting it into OI.
SNMP.
And I ain't saying that. I'm just telling you That's why I say, like, after AIT, if I would come into CCNA, I would have been good. Like, the commands are right after. No, we not.
CCNA has a lot of extra shit though too, like wireless. Like you guys, like the next 2 days, you guys are gonna be like,
Yeah.
it's a lot of shit.
Nah. But these commands that call in, though, call right in. It keeps us going. That's what I would have said. I would like to take this class right after AIT.
In the Air Force, one of their MOSs, they have to get this shit before they leave. CCNA and Sec Plus. Every single airman, yeah.
I don't remember you said that, but
I might just see. I need to get mine.
Tickets for everything. Can't even fix shit ourselves. That's exactly right.
I'm gonna end up getting this. I'm gonna take it.
Yeah, I like the Air Force, yeah. I was in a joint unit, and they were like always the smartest.
I was like,
Yes, you do. You do. You do. You look like a real school professor.
oh, thank you.
from 10 to 11, I will be here. From 11 to 12, I will be here. After that, I'm taking lunch.
More like shit. Don't tell me 11.
I'm
9
glad
o'clock.
y'all know.
9 o'clock, I won't be here. Then I got another one at 11:25.
I'm glad y'all know.
Don't forget that one at 14. I be looking for your ass. I was like, y'all see Davis? What Davis said?
You know what's crazy? Some of them don't even have no appointment. They just be like, she had an appointment.
She said. You show up. Oh, I thought you had no appointment.
Oh shit, I can go back home then.
When you tracking you was coming in.
They sure don't. I just be like, why y'all want me here for? Don't you think I got an appointment? Yeah, but something going on.
All right, guys. Let's go over SNMP. So this is called the Simple Network Management Protocol. So this is a way that we can centrally monitor what we call SNMP agents, which is really just our network infrastructure. So has anyone here ever used SolarWinds? Okay. It's a network monitoring software that the DoD has a big contract with that also had a huge CVE incident back in 2018, but anyways. Do you guys know what I mean when I say CVE? It's common vulnerability enumeration. It's just like the number or code that's given out to exploits. SolarWinds manages all of DoD's like network infrastructure for DISA, and they had a huge one where China or Russia, they don't know, could backdoor into them. So it's pretty crazy, but we still use it. So anyways, and all of our telecoms, you guys hear, they're like compromised by China. Yeah, because they buy fucking hardware from China. What's that one company? Huawei? Yeah. Huawei?
But it's cheaper than Cisco. So what's the
Yeah. Yep. If it's cheap, it's better, right? Yeah. Okay. Sorry, I won't stop talking about that. I like researching China a lot. You'll see me like talk about it a lot because their government is. When I was in Africa, they had like these UN people that were Chinese. They would come around and take photos of our compound, and like I had a CI guy told me one time like that's like on purpose. Like their citizens are like spies too sometimes, the agents of the government. But anyways, I'm just talking about the government, not the people. So if anyone's married to any Chinese people in here, I apologize. All right, so SNMP architecture. So this is kind of different than a client to server architecture. This is going to be more like server to client. What we mean by that is we're going to have an SNMP manager. So that's going to be our NMS server, our network management station server. Think of that as the actual box. That's our Dell PowerEdge server. Maybe it's in the cloud. And then we're going to have our application, our software. So that's SolarWinds. That's the symbol. So we install SolarWinds on our server, and then from that server, we're going to reach out and start monitoring nodes. So from server to client. It's kind of a little bit different than the typical like client to web server architecture, okay? But we have the SNMP manager. You got to memorize this, right? The SNMP manager is the one that monitors the SNMP agents. So this is the server, okay? SNMP manager. The agent is going to be your routers, your switches, your access points, your firewalls that are being monitored via this protocol, SNMP. So SNMP is the actual protocol. So when you guys go to a website, you type in HTTPS, the hypertext transfer protocol is the actual thing that's downloading that web page from the server. That's the protocol. SNMP is the actual protocol that we're going to use to monitor. And then we have our actual software that we need to do it though. SolarWinds is the one I chose. Okay. So the server is going to send SNMP GET and SNMP SET messages to the SNMP agents. That SNMP GET message is going to be asking for information from the agent. So this is a monitoring solution. So we might want to monitor our CPU thresholds of all of our routers or switches. Maybe we want to monitor our caches. Maybe we want to monitor bandwidth. Things we want to monitor, right? So let's say I want to monitor the CPU threshold of this switch here. From the SNMP manager, I would set up an SNMP GET. Okay? Now on the software side, like I'm in SolarWinds, this just looks like, okay, let's add a new switch, put its IP address, put the SNMP user, verification, boom. and then I set up things I want to monitor. So if I want to monitor the CPU threshold, I'll set that up. Now on the wire though, that's an SNMP GET message. Okay? That's from server to client, from SNMP manager to SNMP agent. Now what's in here? So in this SNMP message, we're going to be requesting information from an OID, an object identifier, okay? So SNMP has something called a MIB. This MIB stands for management, you have to know this, information base. Why? MIB. That MIB is going to contain, it's a database, okay? It's going to contain a huge database of what's called OIDs. So in that MIB, we're going to have hundreds of OIDs. OIDs. That stands for Object Identifier. So if I'm on a Cisco router and it's interface gig 00, that has a unique OID. Interface gig 01 has a unique OID. My CPU, any hardware component is going to have a unique OID that's in my MIB, my management information base. So really this SNMP GET message is like saying, hey, R1, send me the percentage threshold of your OID 1.6.5. whatever, and that OID is going to equal the CPU, okay? Another type of message that can get sent, guys, from server to client is SNMP set. So we can't have some advanced feature here that does more than just monitoring. We can also use SNMP to configure. So an SNMP set message will configure something on the agent, okay? So SNMP set, SNMP get, those are coming from the SNMP manager. Sound good? Okay. Remember, this is just a monitoring software, so this is just like us polling the SNMP agents for information and then displaying it on a dashboard that we have up in our NOC, okay? Now, the SNMP agent, they also have, I'm going to get rid of this because I didn't need that. They also have messages that they can generate, but it's not by default. By default, this is the architecture. SNMP manager pulling an SNMP agent, using SNMP get and set messages, and polling for specific OIDs that the SNMP agent has on its MIB, management information base. Okay. The SNMP agent, though, if we configure it, it can send messages to the server as well. It's typically triggered by something. So let's say on our agent, we set up a configuration that says, hey, if your CPU gets to 80%, tell the server. We have to configure that individually on each agent. We call that an SNMP trap message. You have to know that, okay? An SNMP trap is from the agent to the manager, and it's something you have to configure. So if I tell you, hey, we want the SNMP manager to be alerted right away of a configuration change, what kind of SNMP message is that? It's a trap. Because the manager will pull its agents at an interval, 10, 5, 15, 30 seconds. But if I have a change on the agent and I want the server to know right away, I got to set up an SNMP trap. Because that's from agent to manager. Now, something unique about the trap message. Is that we don't expect a response from the manager. So we send that trap and we don't get any acknowledgement back. Nothing. We just sent it. We have no idea if it made it to the manager. If we want to get that acknowledgement, instead of configuring a trap message, we have to configure an SNMP inform message. And when we do that, the SNMP manager will send an acknowledgement back saying, hey, yeah, we got that message from you, agent. Thank you. So they do the same thing, but the trap is considered like unreliable. So the vernacular I'm using, right? SNMP trap is like unreliable. Where an inform message, the SNMP manager has to acknowledge. Okay, any questions on this architecture, guys? Another important thing we have to know for the exam, I can dive deep into this shit, but I'm trying not to, is that SNMP has 3 versions. So check it out. Has 3 versions. So SNMP v1 is unencrypted and does not have secure authentication. Okay? So what do we mean by that? So take a look at our architecture again. I'll drag this up here so you can see it. The manager pulls an agent. The manager reaches out to an agent and says, hey, I'm going to monitor you. But the agent still has to like agree to that. So usually when we want to get access to something, we have to put in a password, right? Okay. So when you guys send a password over Wi-Fi and we're using WPA2, WPA3, it's encrypted. It's not plain text, it's ciphertext. So anyone in the man in the middle couldn't see it. With SNMP v1, it's not encrypted, and we don't have secure authentication. What we have is something called community strings that act like a password, but it's sent in clear text, okay? So, SNMP v1 uses community strings for authentication. It's like a password, okay? Between manager and agent, it's just a password that has to match, but it's sent in clear text, so it's not secure, right? All right, here's something crazy, but you have to know this. They always write it out. SNMP v2 Charlie, the exact same thing, all right? It's also unsecure, not encrypted, and uses community strings. The reason there's 2 different versions is because right here we got like extra features like the set message, like the informs and stuff like that. But they're both insecure. They both don't offer encryption or secure authentication. Now, SNMP v3, it's encrypted and has secure authentication. So you can do both. SNMP v3 messages will come across ciphertext, and we'll also hash our passwords, okay? With SNMP version 3, we also have a username and password, not just community strings, okay? All right. I think that's as far as I'm going to go here. Yeah, that's as far as I'm going to go with SNMP. Let me just show you one thing real quick. Present button. Remember I was talking about the management information base has a bunch of OIDs. This is what it looks like, okay? So if I'm looking for an interface under Cisco, it'll be, my OID will be 1.3.6.1.4.1.9, and then there'll be more down here. You do not have to memorize this though. This is not something you have to memorize at all. When I configure an SNMP manager like SolarWinds, all this is there for me. I don't have to memorize an OID, okay? Just want to show you the structure. Let me see. I have a MIB browser here too. I want to show you guys on my MacBook. So you can see if we want to look at interfaces, that's the OID number, all right? I know it might be hard to see, but. Okay. That is SNMP. Do you guys have any questions on that? Go ahead.
Can different SNMP versions communicate with each other?
No. Well, yes, but like if you're going SNMP v3 to SNMP 2, you won't get the encryption.
Yeah.
Right. It'll just default back to the version 2.
So would you have to set on the manager how you want the entire SNMP infrastructure to communicate? Or?
Yeah, you can have both. Like so, on the manager, you can set up polling for SNMP v3 and set up polling for version 2, and depending how the agents are configured, right?
So when you build the entire architecture, you just have to set everything to v3 or set everything to v1 or?
No, you don't have to. So you could have a switch that's running v2, you can have a switch that's running v3, and the manager can do both.
Okay.
Yeah. It just would be, it's kind of hard without ever having to fuck with SolarWinds before. Like I have, but I don't know if you guys have. Like when you're setting up an agent to be pulled, it'll ask you all that.
Okay.
It'll be like, okay, you're gonna pull this agent. What version is it? You click. Okay, it's version 3. So what's its username? What's the password? What's the IP address? Yeah. Encryption type. It's shit like that. You know what I mean? So it's like on a per use case. Yeah. Alrighty. Last thing we're gonna go over today. It's called syslog, and then we're gonna be done because I can't. Y'all may not see it, but I'm like barely talking right now. It's taking everything. All right. Yeah. Oh, I feel bad, you know. It's like I want to keep teaching, but I'd rather be good the rest of the week. Okay. Let's take a look at this CLI. So when I go into an interface here on a router and I type in no shut, let's see what happens. Y'all see this message that just came up? It's called a syslog message, system log. Network devices, Linux, every device has a system log. Now I think Microsoft may be a little different. I don't know what they have. Yeah, it's not called syslog, right? No. Let's say Unix-based systems have syslogs. This is something that's going to pop up in the CLI to tell you, alert you about something that's happening on the device. So here, the syslog message starts right here at this little %sign. Here we have our timestamp. So we have the timestamp. And then we have this. So it's talking about a link. Here's the severity level. So we have syslog levels. Then here's the action. It went up, down. Okay? So it just means that it flapped. And then we have the message. Interface gig 00 change state to up. This is all syslog is right here, okay? Every single network device is going to have its own syslog where it generates these messages. If we want to, we can take our entire LAN, every router, every switch, and set those devices up to send these syslog messages to a centralized server, which then we at the NOC or maybe at a SOC can then analyze. Or maybe we can take all those messages and forward them to like an SIEM server. You know what that is? SIEM server? SIM? Yeah, how do you say it? SIEM? Yeah. Depending who you watch on YouTube, yeah. SIEM server. And then that SIEM server can take it, aggregate it, correlate those logs, right? You can start putting ML, AI against it, start creating user baselines. What I'm trying to make is syslog can be helpful in your telemetry, okay? But we got to go over the levels, and that's pretty much it for the exam, okay? So let me show you. We're just going to do the slides. If you want to see the syslog, you can just type in show logging, and this will show you all the syslog messages. This is good for like on the network too. If you have a team and you're like, hey, like what happened here? And you think someone's lying to you, you can just check the logs, right? And be like, nah, like I saw this interface come up and down. And when you have users like TACX configured and you have a bunch of users, you can actually see the user that did something, okay? Okay, let's move on. Okay, so syslog, system login protocol, just a standard way for us to get log messages. Write this down, UDP port 514. I think I have it here in your book too. Yeah. Okay. Cool. Make sure I didn't miss anything. Thank you. Okay, right? This is a great way to alert us. You can also start using it for automation, but I'm not going to talk about that, just for the exam. All right, here's the chart I want you to look at. So there's 8 levels of syslog. Memorize level 4 and memorize level 0. Okay? So level 0 is emergencies, level 4 is warnings. Now I've been teaching CCNA for this version of the exam. Well, when CCNA 200-301 came out, since 2020, some tests, there's like 4 questions on syslog, and sometimes you get no questions on syslog. So we're just going to play it safe, right? I'm going to go over things you may have to memorize. Have you guys heard there's a new version of CCNA out? Has anyone heard that? Okay, so here's what, just a little aside here. So Cisco started doing micro updates, not full revisions, okay? So the CCNA you're going to take is called 200-301, and for 3 years that was version 1.0. So 200-301 v 1.0. They recently just did a micro update, a little update to that, and added 3 new technologies to the exam objectives. That's all that happened. And they got rid of a couple things. But still the same 200-301 exam code. Make sense? Now it's v1.1. Okay. Kind of got off track there. So level 4 through 0 are error messages about software or hardware malfunctions. Level 5 is just notification. We come back here, scroll up, let's see, where are we at? There's the levels on the actual screen, okay? So level 5, what is that one? Notification is just letting you know something happened on the device. Levels 4 through 0 means that something may be malfunctioning, maybe, right? Level 6 is informational, so like if you assign a license or something. Then level 7 is debugging commands. Okay, and this is just going over what I just went over for you. Okay, move on. Sometimes you have to configure timestamps. So on some iOSs, timestamps aren't just automatic. You have to configure it. Remember we talked about NTP, Network Time Protocol? This is where it comes very important, right? Because if our router went down, we may want to know what time to correlate it to a certain event. And if your timing's all fucked up, this could be, your timestamps are wrong, right? So for like forensics, like analysis, root cause analysis of why something may have went down, timestamps are very important for our logs. You probably know that, right? Like timing being important for this kind of shit.
Yeah, I mean, like we were talking about the NTP server, if it's not configured when you build the server or something like that, it won't even work.
Yeah. So timing's important.
Or it won't connect.
All right. Default login, we need to go over that. So this is an example of like a basic syslog server. It's called Kiwi. And it'll send syslog messages to this server, Flamer network devices. If you want to configure that, you can do it here. The command is just logging, and then the server you want to send the messages to. And then you also have to tell it like what level, because maybe we don't want to send everything, so we just want level 4 and down, which is our emergency stuff. That's that logging trap command. And then, yeah. Okay, cool. Just some more show commands to show the logging. So obviously on like a real device, you're gonna have a fucking huge log, right? So you wanna filter it out. If like an interface, a tunnel went down last night, you don't just want to hit show logging. You have to go through a log that's like 6 months old. You may want to filter it out. So you may want to put pipe begin, then the date, right? To say, okay, I need to just check everything from 8 p.m. last night. Make sense, guys? Okay. Won't be on the exam though, but just real world shit. All right, cool. That's it for the day. We're going to go home now. If y'all want to study here till 3, you definitely can, but you can also study at home. Here's what we're going to do. Before we leave, you guys are going to have to go over some lessons. And we're going to go over it tomorrow, so please watch the videos, okay? So here you're going to go to section 6. And you're going to do section 6.07 all the way down, okay? If you want to skip the labs, that's fine. You don't have to do the lab videos. But quality of service, you're going to watch all these videos. Go over FTP and TFTP. And then SSH, okay? I'll put the exact sections and numbers in the signal chat because you don't need to watch the lab videos. Like I have a video just of me configuring this shit, right? But you don't need to watch that. But yeah. Tomorrow, we're going to do a little out of order. Tomorrow, I'm going to go over security. We're going to skip wireless, okay? So tomorrow, I'm going to go over security. I'm going to go over WAN architecture. Wednesday is going to be a whole day of wireless, okay? I'm going to bring in a wireless controller. I'm going to bring in another computer. I'm going to bring in like access points, and we're going to do a whole thing, all right? And then by Thursday, Friday, we're pretty much going to be done. It's just going to be questions. Sound good, guys? So that's the rest of the week. All right. Have a good day. Hopefully my voice is good tomorrow. It should be.
It's saying this is a race.
Mm-hmm.
If you add all of this up, it's pretty much coming up to 79, and this one comes up to 54. But the explanation was there's a big difference between right here, 0D, 0E, and 0D, E, 0.
Let me see. Touch screen. So you're saying you think it's A?
Yes, I put
Okay.
A because it adds up to 54. Okay, then the second one adds up to, I think, 78.
Mind if I?
No. This man moved in on what, Thursday night, and then I came to his room the next day. And he was
13, 29, 38, 39, 50, 55, 64, 71. Okay, that one's 71. Here, just leave a comment, and I'll look at it right now. Okay? Yeah. And if I can change it. Like if you're right, I'll just change it, and then it'll be good. Yeah. Yeah, yeah. No worries. I appreciate it. Yeah.